In this video, we will be looking at rotations in geometry. There's a few important rules that we should talk about when we look at rotations, but first let's look at the rotation notation. Here we see a capital R, and it's important that you use a capital R because a lowercase r is used for reflection. And so just a trick to remember that you use a capital R for rotation is that if you were to spell out the word rotation, you start with capital R and then an O, and there's an O in that capital R. So capital R, rotation. So here we are given a point that we rotate around, and most often it's the origin. So sometimes they'll write the origin, or sometimes they'll just leave it out, or they'll give you the coordinates 0, 0. It's okay if it's missing, as you'll see in these rules here. You don't see any words like origin, you don't see the coordinates 0, 0, but it just means that we're rotating around the origin. And then they give you a degree measure, such as 90, 180, 270. Those are the most common degree measures of rotation, but you could also do things such as 60, 30, any number of degrees of rotation. But when we're looking at it graphically, we typically stick with 90, 180, and 270. So here, as you can see, I boxed in those rules. They're important to us, but I'm also going to show you how to use it graphically, or do this graphically. So I'm going to start by plotting triangle ABC in example 1. A is located at 2, 2. B is located at 2, 7. C is located at 5, 2. Okay, so our first step is to rotate triangle ABC 90 degrees. And when we rotate, it's important to remember that we are going in a counterclockwise direction. Here, positive always gets rotated counterclockwise, negative degrees always gets rotated clockwise. So if I'm going to rotate triangle ABC counterclockwise by 90 degrees, what I need to do is take my paper and physically rotate it 90 degrees, meaning one turn to the left. And so what I'm going to do now is list those coordinates that I see right here. And I'm going to focus on this as if it's a new XY axis. So for example, A prime will be located wherever A is currently, -2, +2. B prime will be at -7, +2. And C prime will be at -2, +5. Once I have those coordinates written down, I can turn my paper back, and then I'm going to plot those coordinates that I wrote down. Yes, it's annoying because they're written sideways, but it's okay. You can still deal with it. You can turn your paper back if you need to. But I'm going to start plotting. A prime is at -2, +2. B prime is at -7, +2. And C prime is at -2, +5. So when I connect, I can clearly see that I did in fact take my triangle ABC and rotate it counterclockwise 90 degrees. My next step is to take the original triangle ABC again and rotate it 180 degrees. So when I do this, instead of just turning one time to the left or counterclockwise, I'm going to take my paper and turn it not only once, because that's 90 degrees, but I need to take it and turn it one more time to be at 180 degrees. So now again, I'm going to take this and look at it as a new XY axis. So here I'm just going to, I thought I was going to erase, I guess I can't. I'm going to look at this here as X and Y. So now A is over here, but that means that A double prime will be located at -2, -2. B double prime will be located at -2, -7, and C double prime will be located at -5, -2. So again, I'm going to turn my paper right side up, and then I'm going to take a second to plot those points. Yes, again, it's upside down, but that's okay. I can still read it. -2, -2 is A double prime. -2, -7, B double prime. And -5, -2, C double prime. Okay, so we are 3/4 of the way there. Our last step is to rotate triangle ABC 270 degrees. So again, I'm looking back at my original triangle, the one in blue, and I have to rotate my paper 270 degrees counterclockwise. So that's one turn is 90, two turns is 180, and my third turn is 270. So now I'm looking here at a brand new XY axis again. I'm focusing here on the purple and then in the triangle in blue. A is currently located at 2, -2. So that means A triple prime is 2, -2. B triple prime is at 7, -2. And C triple prime is at 2, -5. So I'm going to turn my paper back last time, and then I'll be able to plot those last coordinates. 2, -2, 7, -2, and 2, -5. So there's a lot of important things to notice as we're looking at this. Each time I rotated, the triangle went counterclockwise. That's again because we were rotating in a positive degree direction. And each time I did this, I jumped one quadrant towards the left. And we label our quadrants starting in the upper right as 1, moving to the left as 2, downwards is 3, and ending in the bottom right is 4. And the way that we think about this is as if we're going around, starting in the upper right with the letter C. So here I'm moving one quadrant each time I rotate, because I'm rotating 90 degrees more than the last time. And also we can look at this here. If I'm rotating clockwise, unlike what we did, but if I were to rotate clockwise, this blue triangle would map on top of the purple one. And although originally the purple one was a rotation of positive 270, if I were to rotate clockwise, this is a rotation of -90. And that leads us to our next example here. A rotation of a negative degree means to rotate clockwise. Therefore, a rotation of -270 is the same as a rotation of +90. So although we didn't look at that one, we can. If I were to rotate clockwise, going this way, 270 degrees, the blue triangle would map on top of the green triangle, which was the same as a rotation of +90. The next spot says a rotation of -180 is the same as a rotation of +180, going counterclockwise. And then as we saw in the first time I showed this to you, a rotation of -90 is the same as a rotation of +270. I just also want to point out to you here that in this first example, we chose to do it graphically, but we could have also used the rules. So here, if I were rotating 90 degrees counterclockwise, I should take my x and y coordinates and switch their spots and then negate the y. So if I were to look at, say, B, for example, and apply that rule, -y, x, that 7 would go to the front spot and the 2 would come to the back spot, and then I would be negating the front spot because it goes from x, y onto -yx. And you can see that that's exactly what we found when we did it graphically. So either using the rule or using the graph paper will work for you. A lot of students think that using the graph paper is easier because it's a physical example. And then our last question here is related to the clockwise rotation. So here it says, what are the coordinates of the image of A, negative 3, 4 after a clockwise rotation of positive 90. Now, if we're going clockwise, that means that it's actually a negative 90. And negative 90 is the same thing as a rotation of positive 270. So here, I want to take this point A, negative 3, 4, and rotate it positive 270. And now again, you could use the rule, or you can use it scrap graph paper if you have it by you. But the rule says that I want to switch their spots, X and Y, but negate the back spot, the Y. Or the X, I'm sorry. So here, A maps onto A prime at 4, 3. So again, I swapped their spots, and then I negated this back spot. It was a positive, or a negative 3, and now it's a positive 3. Go ahead and stop the video so that you can rewind if you need to, or you can move on to your practice.